All right, sorry for the false start. Thank you again for coming to our presentation. We are covering our project, the PYIP-Skimmer, which is implementing an IP address management system in Dell Compellent Send Test environment. This was a joint project between UW-Stout and Dell Compellent. Our Dell Compellent team was Steve Holm, Master Engineer, Mike Madsen, Senior Engineer, and Jacob Medford, Master Engineer. Oh, sorry, one second. Congratulations, Mike Madsen, on your recent promotion to Master Engineer. Your capstone team for this project was myself, Dean Floriani. I am the team leader.
I'm Benjamin Adams. I was the audit and backup code leader.
I'm Joseph Conkle. I was the database lead.
Brian Mullen provided our user interface code lead.
And I'm David Voigt, the test environment and validation lead.
For our PowerPoint presentation today, we'll be discussing our problem statement, our project details, our implementation of our project, and provide a live demo of the project in action. And at the end, we'll wrap up with conclusion and questions. So what kind of problems does an IP management solution address? I want to be able to monitor my address space and be able to view networks in use and available across different networks.
I need an IP address for a new device.
I am planning a project and I need to reserve a range of addresses.
Or there's a device in my network and I want to know who's responsible for it.
So what we addressed with our project here is Dell came to us at the beginning of the semester with the challenge of creating a system that could track and document IP addresses over a dynamically changing and statically addressed test environment that's utilized by over 75 users at any given time during the day and encompasses 3,000 IP addresses. The goal for our project was to kind of expand upon the functionality of what you've seen before in managing IP addresses where you have a spreadsheet and with IP addresses featured all over your with IP addresses and usernames and hopefully access and passwords and that kind of thing. With spreadsheets, it's difficult to maintain that kind of update. There's not really, user tracking on who made changes previously, and there's really no information on how to scale those up. If you try to get multiple people using that at one time, it just kind of gets all messy. So,
we told Dell Compellent challenge accepted and looked at the constraints of this project. As Dean had touched on earlier, this is a static IP environment, thus eliminating any kind of DHCP-enabled IP address management solution. This solution had to be open source or custom coded. This would allow Dell Compellent to manage the software in-house, not relying on any kind of third-party technical support. This program also needed to have a web-based user and administrator interface, two separate interfaces to control what users can see and do in the program versus what the administrators can do. It needed to be web-based just to provide ease of access, eliminating any need for users to install an individual program on their machines. Our fourth and possibly largest constraint for this project was our 3-month development time frame.
So, for the course of our project, we identified 4 main deliverables that we were to provide to Dell Compellent. The first deliverable being the actual running program, which, as my group mentioned, is a program that runs and is accessible from a web interface with 2 separate interfaces for admin and user use, and is able to track static IP addresses in a database, allowing everyone on Dell's lab environment to be able to access it and add their own IPs. The second deliverable is a packaged appliance, which is essentially our program packaged along with any applicable operating systems that Dell needs to install our appliance on their lab environment. The third deliverable was a user guide, which is essentially a high-level guide detailing how to use our product. It should be user-friendly. Anyone should be able to read it and learn how to use our product fairly easily. This gave us an opportunity to really make a user guide on a product that really doesn't have a lot of previous documentation. So we learned a little bit through that, and we also learned how to kind of create a guide that is actually going to be used in a test environment. And finally, for our fourth deliverable, we were to provide a white paper which basically describes our program, our problem, how we came up with our solution and our process along the way.
So in order for us to actually complete this project, we had to mimic Dell Compellent's test environment within our lab. We kind of did this with some equipment that was donated by Dell. They lent us 2 PowerEdge R310 servers and donated 2 SAN controllers and 3 SAN hard drive enclosures. We also used equipment that was lent to us by UW Stout IT Lab. We have a Cisco 2811 router, a Catalyst 2960 switch, and 2 more HP servers. Our topology was actually a fairly basic topology for this. We have the internet coming into our router, which handles the basic NAT conversions as well as all the basic routing. We have our switch, which separates all the data into the separate VLANs, which then goes down into our 4 servers, and the 2 controllers, which then also connect into our SAN enclosures. On the virtual side, we have 3 of our servers that we use for virtualization. We have Alpha, which is our test environment, and also holds our final solution. Charlie, which is our management, and also has some more of our test equipment. And then Delta, which is our main remote, our main remote in server, and also handles our Exchange 2016 server. It was actually kind of a long experience setting up our Exchange server, as we started with 2010 and found out that when we virtualize it, it likes to steal extra resources and kept taking down our server, our physical server. So we moved on to 2016, which was new for all of us as we haven't really worked with it, and kind of a learning experience, learning how to use it as a web-based admin interface opposed to having the wizard side.
So after we set up our test environment, we began looking at the development process. And really what we started looking at first was how should this program be created? How would someone come in and start using it from the beginning? So what we sat down and designed this address registration workflow. And what we determined is a user comes in and needs an IP. They have planning a project, they've got a new device they need to test on the network, or there's an existing project that they're expanding. From there, they would access the database via a web login and be able to view available IP addresses within ranges. After choosing an IP address or a range of IPs, they should be able to claim the IP, and then the database would register it as being owned by them, and then it would change the status of the IP in the database. And then finally, the user could go and configure their equipment while the database maintains a persistent record of that IP being used.
Now that we had the test environment set up and had a basic working knowledge of how we wanted the program to run, we decided to start coding this program. The backend coding we started with using Python and pretty much used that to get all the backend set up. Once we got that set up, we started researching website, front-side programming. We used the Django as our main web framework for the program, but as we got further into it, we realized that with the time constraint that we had on this project, we weren't going to be able to provide Dell Compellent with a fully operational software that met all the requirements that they needed, so we decided to actually start looking into open source software solutions.
So as we began looking at open source solutions, we came up with a few. The first one we looked at was called Network IP Application. It was a very good application to be able to access a web interface of a database of IP addresses for users to manage. But we felt like it was really bare bones. It didn't provide a lot of the things that Dell Compellent had asked for, such as a separation between an admin and a user interface. And thus we began looking at different open source solutions.
We then took a look at an open source software called YesGeoIP. YesGeoIP did a lot of what was asked for in the statement of work. However, we felt that it was lacking in some of the more key areas of the statement of work. It lacked Active Directory integration, which we felt was important to provide Dell Compellent not only with accountability for who was making changes to the database and when those changes were occurring, but also to provide a single sign-on solution, which is so desirable for businesses nowadays because it makes password management that much easier. In addition, configuration and database backups were not a feature of the free version of this software and would require the purchase of additional licensing.
So the final solution that we looked into before we found the one we actually went with was TeamIP. TeamIP was yet again another solid open source solution, had a lot of the features we were looking for. However, it did not have any email notifications built into it that we were looking for. Dell Compellent expressed that they really were looking for this so they could easily track device status changes on a 24-hour basis, new devices that were added but not registered with the software, so that they didn't have to constantly go into the software every day and see what was going on with it.
The open source solution we ended up utilizing as the base for our project is called PHP-IPAM. PHP-IPAM provides clear visual representations of networks. It provides email functionality, and additionally, it allows for user and administrator separation with Active Directory integration. To begin with the implementation of our project, we had to look at what PHP-IPAM provided and go and develop off of that from there. PHP-IPAM gives us the ability to integrate Active Directory, have a database with our information be through MySQL, and provide email functionality for reporting. From there, we built in functionalities for database backups and restores, and additionally included a method of scanning the networks with a MAC address scan that updated the MySQL database with the relevant information for the IPs that it was able to scan through.
So after configuring the functionality of PHP-IPAM, we tested that functionality against a Dell Compellent approved testing plan. We tested many different things, including browser compatibility and user load testing. This was a new process for all of us, and in building and going through this testing plan, we learned a lot about how important thoroughly testing a program is before it is deployed into a production environment. After running through our test plan, we began to package this product into an OVA to be delivered to Dell Compellent.
I want to touch a little bit on the custom scripting that we did in order to provide the database backup functionality, as well as a few other things. So with our database backup functionality, we had created a script that touches the database and performs what's called a MySQL dump. And what that functionality does is it takes an entire database and puts it all into a single file. From there, this script then zips that file, dates it, and provides the ability to go through and scan the database backup folder for any database backups that are older than 14 days and delete those. It logs all of these actions in separate log files from the creation of the database backup to the deletion of older logs, or older backup logs, excuse me. So what's a backup without a restore function? This restore function is a manually initialized program where you have to go in, provide the information for the database that you'd like to restore. It unzips the database file, deletes the existing database in PHP-IPAM, restores the database from the backup file, and then rezips the database backup file that you used. An interesting part of this was they requested that we provide a way to have a "Are you sure you want to?" And our script is makes you type in "I know what I am doing" before you can continue to restore that backup. And finally, to touch on our MAC address scanning. This was actually pretty interesting to implement. What this does is it pulls the subnet information from PHP-IPAM's MySQL database, passes those subnets to be scanned by Nmap. Nmap scans those subnets and creates a file, a text file, with the relevant information. And from that text file, it updates the database through MySQL to reflect those changes. Finally, what kind of projects would this be if there wasn't automation? Since automation is king in today's IT world, what we did was we added these scripts that could be automated, such as the MAC address scan, the database backup, and including the functionality from PHP-IPAM with the ping check and the discovery checks that are automated, to the cron jobs to be completed once every 24-hour cycle. They are completed over different periods of time in order to reduce load on the server.
Now for the live demo, what we're going to do is we're actually going to play out a scenario of our capstone company decided to add in interns for the first time. Joe is going to act as our intern. What we're going to start off with doing is we're going to create the group of interns, add in the users, add in Joe as a user into that group, then add that group to a section of IPs. Then is that going to go into that and then actually add in the subnet that he's going to be able to access, add in hosts that are already on that subnet. And we'll see Joe go over what he can see on his interface side, and then move on to the final, demoing some of the reports that we get from emails. So to start off with, we're just going to go into the administration tab, which will show you all the things we can do on the admin side. And we're going to go to groups. Within the groups, these are essentially where you can group all the users together that you want in a specific, to be able to see specific things. So we're just gonna create a new group, and we're gonna name it interns for this demo. Once we add that, you'll just see it populate, and you should see it show up underneath capstone. From here, we're just gonna go into the users to add in a user to that group. We already have this user created on the Active Directory, so once we click Create Users, we can actually just click this magnifying glass next to the username. From here, we'll actually search our domain with the first 2 letters of the intern, and you'll see we'll actually have 2 interns coming up on here. We're just gonna use intern, the normal intern for this. It'll automatically populate the real name, username, email address, and also change the authentication method to Active Directory. There's 2 different types of roles that you can have for the users, either a normal user or administration. For this, we just want a normal user. And then we're gonna select the interns group that we want them in. And we'll add the user. And you'll notice it'll not only update, but it'll also send out an email notification to both the user and to the administrators. From here, we'll add that group into the section, which will be under IP-related management. We already have the interns group, or intern sections selected or created, as there's a lot of back-end stuff to this. So we're just gonna edit that intern selection, and we're gonna change the interns permissions to RWA, which is read, write, administrate, so that they can also add IPs or reserve IPs and delete those IPs as they need. And we'll just edit, and you'll see it's successfully updated. That is not gonna go over to the subnet creation side of things.
Okay, so now that we've created a user, added him to a group, and added the group to the section, we want to create a subnet which is under that section, so all our interns will be able to add IP addresses in their own intern subnet and make their changes to our lab environment. So we're going to go into the subnets tab, and we'll see we have an intern section in here. Right now it's empty because we haven't added a subnet, so we're going to click the Add Subnet button. And we'll see a lot of information boxes pop up here. What we want to use for our network statement is actually a network that we already have on our lab environment in the computer lab at Stout, which is 172.18.80/22. And then you can add a description. This is going to be our intern subnet, so we'll call it intern. And then our VLAN, which is linked to this subnet, is VLAN 30, our intern VLAN. So we can drop down and select that. And then the device these IPs are located on is going to be a switch. And then the name server that we previously set up on our lab network is pre-configured, so we can select that here. And then we also want to check yes to check host status and discover new hosts, which will allow the program to be able to scan this subnet for any IPs that are active currently. And then we also want to enable IP requests. So this basically allows a basic user coming into the network to request an IP to be added to this subnet to document that and store it into the database. So now we're going to click Add. And it will say subnet add successful, and we see the new subnet here, and we can enter it. And this basically, this page gives a visual representation of all the IPs that are being used in the subnet. Right now, you don't see anything on here because we haven't added anything. So the first thing we want to do is scan the network for any alive hosts. So we're going to do a discovery scan, which is, it pings all of the IP addresses in the subnet and comes back with anything that's alive. And the second type of scan that you can do here is a status update scan, which would, if you already have hosts on the subnet, you can scan it again to make sure they're still online. The scan, it really doesn't take that long to complete. You'll see complete here in a couple seconds. And we found 2 hosts that are on our network right now. These are IPs that we already have, we just found them. So the 253 addresses are switched, so we can describe it there, and the 254 is our router. And if we click Add Discovered Hosts, it will automatically add them to the database, and they'll be stored in there forever until you delete them. And then you can see the online status to the left of the IPs. Now we're going to go over to Joe, and he's going to show a little bit of his side of the intern side of the interface.
All right, so today is my first day as a brand new intern. I just got my first project. So I'm super excited, but remembering my training, I'm going to consult the PHP-IPAM database before I configure any devices. So I'm going to log in with my Active Directory credentials here. And as soon as it finishes logging in, you can see in my menu, I can only see my intern section. The interns are completely separated from the full-time employees. The full-time employees don't want anything that we break to break their stuff. So I'm going to click on my intern section, and then my intern subnet. And I need a range of a few IPs, so I'm going to click the green plus sign. And through this menu, you can enter a singular IP, or you can enter a range. You can enter a range just by inputting your starting and ending IP addresses. There are many fields that you can fill out here. In the interest of time, I'm only going to fill out a couple important ones. My description of my devices, the owner of those devices. Tag it as used, just so other people know that those IP addresses are reserved. And then my date registered and the location of those devices. And once I'm done inputting all that information, I'm going to click Add IP at the bottom. And after a short amount of time, those IP addresses will be added not only to the list view there, but if he scrolls down further, they'll be shown in the visual subnet display as well. So there's two different ways to view which addresses are being used within the network. Now that my project is over, I'm going to go back and I'm going to delete those IPs. I'm simply going to go to the list and click the X at the end. This menu will pop up, just kind of giving me details on what this IP is, so I can make sure I'm deleting the right one. I'm going to hit delete IP and it will ask for confirmation. And once I confirm, that reservation will be removed from the database, and that IP address will be available for use by anyone.
So now that our test network has been up and running for a while, we have a couple email reports that have come in. The first email report that we get in every day will be a status change email. This will pretty much just list the device, which will be our Windows 8 machine, the IP address that it is currently on, the subnet that it's at, and the section that it's in. And you'll also see when it was last seen and what the device changed. This has gone from offline to online. The other email that's probably more important is the discovery email. What this will do is it scans your entire network, and any devices that are currently live on your network but not registered with the software will come up in this email. You'll see both the IP and the subnet that it's from and which section it should go into. This will also automatically add it into the software as auto-discovered, so you can then further go on to find out who those equipment are being managed by, and then let them know, hey, can you update this for us? This project itself has taken many hours for us to go through, from setting up the test environment through this this PowerPoint. We as a group has spent a total of 478 hours. Most of it has been pretty well spread out. Big jump at the end here, going over not only getting this PowerPoint ready to go, but also packaging up the software, making sure we have all the configurations ready to release to Dell.
We began our journey with the idea of developing a custom software from the ground up. And as our project evolved, we evolved too. And we made choices to include an existing open source product and build on top of that and provide the functionality to meet the state of the art. This project really challenged us by providing us the opportunity to take on roles that we hadn't had before, between software development, Q&A, testing, writing the test plan. And it really challenged our skill sets and really provided us a way to grow as IT professionals. We'd like to thank Dell Compellent for giving us this opportunity, as well as the UW-ITM program for providing us the means to do this. We'd like to thank Holly very much for the time that she spent with us, making sure we were ready to go. And we'd like to thank everyone here for coming and listening to our presentation. At this time, we'd be happy to answer any questions or go over anything we might have missed in our PowerPoint that needs to be covered.
Where did you hide Brian at?
Brian's dealing with a family emergency.
Oh, okay.
This guy doesn't know till this morning, so they have to do like a risk control disaster recovery. This
That's what we were kind of
so,
wondering.
yeah, they do pretty good. Yeah, no, it's kind of.
And our PowerPoint actually somehow got changed. We missed a couple slides, got deleted out, so that's kind of where some of the little stutter steps at the beginning of the our presentation was from.
Any questions about the project, or? I mean, we're pretty proud of what we came up with and what we've done here, demo-wise. If there's any questions, I can answer.
Is PYIP like open?
Yes, it's completely open source. There's no, as far as we can tell from reading it, there's only one guy that really is in charge of developing it. We wanted to choose an open source project that was in continual development, so that maybe going in the future, if Dell Compellent decided they'd like to update or upgrade their functionality on this, it'd be an option for them.
Kind of along that continued development, we actually ended up upgrading to a different version of PHP-IPAM rather recently here to add in a few more of the functionality that it didn't originally had, so.
I was going to segue into that story. What's interesting is, as a standard user, you cannot scan a subnet using this function here. You can check your individual IP addresses, and you can check any individual IP, but you can't do a global scan. We're not sure yet from the documentation that the developer of the software provides if that's an intended function or if that's a bug. And while we were working with this software, we were attempting to try to resolve that issue. It's a little bit above our understanding of PHP, and we made a good go at it, but I wasn't able to say that, that's something we could include in the presentation as something that's, complete and show all that off. So it's something we're still continuing to look into.
Any other questions?